So if you brought your calculator, I guess this is probably the first time that this semester that we actually have a little bit of use for your calculator. There isn't anything that we get in section 1.5 that is, really necessary to use a calculator. But if you have one, it might make your life a little bit easier. So what we have coming up is our first test. So today we're doing section 1.5, which is the last new material for chapter 1. Section 1.6 that we do on Tuesday is really a practice test. It might not even be called section 1.6. It was just called chapter 1 review. The idea will be that when we get the test on Wednesday, that there shouldn't be any problem on the test that's noticeably different than the chapter 1 review. So that if you can do all the problems on the review, you should be completely fine on the test. It's basically a lot of factoring and solving equations, and the solving equations we'll do today. A big deal on the test is not to confuse the problems, and after we get done with today, I'll make a big deal out of when you factor and stop, and when you factor and get numerical answers. So today's section kind of puts the confusion into chapter 1 in that we do more for today's problems than we did for the other problems. But anyways, we get a test on Wednesday. Thursday, we start chapter 2. And section 2.1 really is kind of obnoxiously long. It will be the case that I'll feel a little bit rushed when I lecture on Thursday. If you have the time after Wednesday, it would be nice if you watch the video for section 2.1, which means going to my webpage and clicking on the link that says chapter 2 video. If you have the time to watch that, it will make Thursday's class, very leisurely. And if you don't have time to watch that, then Thursday's class might feel a little bit rushed, because there's a lot of material in section 2.1. When I lecture on 2.1, if you've watched the video, it will be almost a duplicate of that, so it'll make that day really easy. In addition, when we start chapter 1, I passed out the problems that you needed for chapter 1. You need to print these out yourself. So for Thursday, you should print out at least the chapter 2 problems. Probably the answers would be good too. But I'm not passing them out anymore like I did for the first day. And then on Monday, since this is, right now this is, because some people will be watching this video way in the future. This is fall 11. For Monday, it's Labor Day, so there's no class. That's all of GCC. And then on Tuesday, we'll pick up again with section 2.2. For some students, chapter 2 is the hardest chapter. It's a chapter on fractions, and it's basically factoring and fractions combined together. And factoring isn't always the favorite skill for students, and then fractions on top of it make it hard. So it's always, if you have the time, a great idea to watch my videos before I lecture. It would reinforce the lectures that I give, but especially on Thursday. And then I don't know when the next test is, but it's not going to be next week, because chapter 2 I think has 7 sections. Basically we do 1 section a day, so probably the week after next week we'll get a test over chapter 2. Every chapter is worth 100 points. So the chapter 1 test, generally the material for most students is easier on chapter 1 than it is on chapter 2. So on the tests that are over easier material, hopefully you rack up some extra points so you can afford to miss some points when we get to the tests that are a little bit harder. Generally, chapters 1 and 3 are the best tests for the semester for everybody. And then between 2, 4, and 5, one of those tests you might find to be your hardest tests. But not every student has the same hardest test, but a lot of students do. For chapter 2 is their hardest, but not everybody. So I can do any problems from section 1.4, which is factoring with cubes and squares. I know from giving tests in the past over chapter 1 that the cube problems and the sum of square problems are commonly missed. So on the test, there's more than likely going to be a problem that asks you to factor with cubes. And of the 30 of you that are enrolled, I don't know, unfortunately like 18 will miss it. So it's hugely important to be able to pick out problems that are cubes, pick out problems that are squares with pluses, and to know what to do and what not to do. So if you have any questions, I'll answer them. If you don't have any questions, I'll force you to do some.
Maybe 21 and 23.
Sure. So 21 and 23 in this section are both cube problems, and they're kind of hidden cube problems because, well, 23 is more hidden, but section 1.4, number 21 and 23 are cube problems. 23 is probably a little more advanced than I'd expect to see on the test, but 21 is very, very test-worthy. And the most common wrong answer that I'd see for 21, so if you were asked to factor this, because the exponent has a 3, you might notice that it's a cube problem. The most common wrong answer would be to write 2x minus 3 quantity cubed, or equivalently 2x minus 3 times 2x minus 3 times 2x minus 3. If you wrote either of those down, if you thought to write either of those down, they're both wrong. They both, if you FOILed them out, they mean the same thing. 2x minus 3 cubed means 2x minus 3 times 2x minus 3 times 2x minus 3. And both of these would FOIL to a mess. They would have probably 4 terms in their answer. And they're both wrong. So if you thought that that was the correct way to get the answer, that's wrong. And this is, when I say 18 of the 30 students will make a mistake on this on the test, this is a mistake that I see more often than not. When you're factoring cubes, you get 2 parentheses. The first parentheses has 2 terms, and the second parentheses has 3 terms. So when you're factoring with cubes, it's not intuitive that the factoring gets way bigger than the original problem. And in order to factor cubes successfully, first of all, you have to realize that it's just not the quantity, something cubed. You get 2 different size parentheses. Then you have to get the signs in the parentheses. And then fill up the parentheses. So usually I say SOP for signs with cubes. So this is a cube problem because the exponent on the x is a 3, which is a multiple of 3. The numbers 8 and 27 are cubes because 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. And for my signs, in any cube problem, I get the same sign as the original problem. The same sign of a minus is a minus. You only get 1 sign in the first parentheses, 2 in the second parentheses. The signs in the second parentheses, I get the opposite sign that I just put in. The opposite side of minus is plus. And in cube problems, the second sign in the second parentheses is always plus. And then underneath the beginning problem, I'm going to write what makes each a cube. 8x cubed is a cube because it's 2x times 2x times 2x. And 27 is a cube because it's 3 times 3 times 3. And when I go to fill the parentheses up, the first parentheses gets 1 of each, which means 1 2x and 1 3. And because the 8x cubed was written first, the 2x that comes from the 8x cubed should be first. Because the 27 that was written last, the 3 that comes from the 27 should be written last. And now I'm going to go in pairs. I'll say in pairs and multiply to figure out the next parentheses. So the first pair that I get from when I wrote down my cubes is 2x times 2x. I'm going to multiply those. To multiply 2x times 2x, I multiply the 2's together. 2 times 2 is 4. I multiply these x's together. X times x is x squared. So I made a pair. I multiplied it. That's going to be the first thing in the second parentheses is a 4x squared. Then I'll make my next pair, which is 2x and 3. I made a pair, and I'm going to multiply. And when I multiply 2x and 3, I just multiply the 2 and the 3. So I'm going to go 2x times 3. I multiply the 2 and the 3 and get a 6, and I leave the x alone. And then the last pair that I get is 3 times 3. I make a pair, then I multiply 3 times 3 is 9. This is the answer to how it factors. That second parenthesis is always prime and it doesn't factor. 23 is essentially the same problem, although it doesn't look like the same problem. 23 is not a cube problem how it's written, because 16 isn't a cube, nor is 54 a cube, because 16 and 54 can't be written as something times itself 3 times. But both 16 and 54 are divisible by 2. So the first step in factoring 23 is to factor out a common factor of a 2. So first, I'm going to remove or factor out the GCF of a 2. And when I do that, it'd probably be nice if I wrote an equal sign. I wouldn't take points off if you didn't. But I'd write a 2 and then a parentheses. And then because I didn't factor out a negative, I don't change any signs. The only time I've ever factored out a negative is if the first term that was written is a negative. Because 16 doesn't have a negative in front of it, I won't factor out a negative. I'll just leave the minus sign alone, divide the numbers by 2. 16 divided by 2 is 8. Leave the x cubed up front. 54 divided by 2, I might need my calculator, but that gives me 27. So this is the beginning of the factoring. Now I need to factor what's left in the parentheses. It's not always the case that what's left in the parentheses will factor, but that's the case here. So now I'm going to factor the inside of the parentheses. And the beautiful thing about this is that's exactly the problem that I just factored. So this 8x cubed minus 27, I know exactly how that factors because I just factored it. So in place of the 8x cubed minus 27, I'm going to write 2x minus 3 times 4x squared plus 6x plus 9, because it's going to factor the same way. So the only difference between these two answers is in 23, I get a 2 out in front of the parentheses because that's a common factor. And then inside the parentheses, I'm going to get a 2x minus 3 and a 4x squared plus 6x plus 9. Is that all right? So guaranteed there's going to be 1 cube on the test. I doubt that there'll be 2. I think there's going to be 20 problems on the test worth 5 points each. So if you would have written one of these common mistake problems, that's just that's a -5 immediately, no partial credit for that. And then the problem on the test, it may be more like 21 than 23, but it probably wouldn't even have the 8 in front of the cube term for what it's worth. The problem on the test might be more like 15, where it says factor x cubed plus 8. More out of that section?
I have a quick question.
Sure.
In your test, do you give partial credit at all?
Yeah, I give partial credit, sometimes a lot, sometimes a little, just depending on what your mistake is. A lot of times, like, I'll be writing my key, and I'm supposed to multiply 2 and 3, but I write 6. I wrote 5 instead of 6. That's like a -1 kind of mistake. So it depends if it's just a silly math error or if it's a conceptual error, how much partial credit you get. But yeah, there'll be probably a decent number of students on this test that get like 97 and 98. And they might miss 1 point on one problem and 2 on another. So yeah, I give partial credit.
On 11 and 12, you said square problems with
Yeah, square problems with pluses are prime, and that's also going to be on the test. That seems to me like it's the first problem on like the 3rd page. So for cube problems, cubes with pluses and with minus both factor. You're not going to get a prime with a cube problem. And they factor, so the first parentheses has 2 terms, and the second parentheses has 3 terms. So they're complex factorings. But for square problems, squares with minus factor, like x squared minus 25, but squares with plus are primes. So a problem like x squared minus 25, it's a square problem because the exponents even are a multiple of 2. 25 can be written as a number times itself. So these are both square problems. The top one, x squared minus 25, it factors. And the nice thing about square problems, when they do factor, they're easy to factor. You get two essentially identical parentheses, except one has a plus sign, one has a minus sign. You divide the exponent on the letter by 2. You take the square root of the number. But square problems with pluses are primes. So it's super easy to lose 10 points on the test, and it's not uncommon for students to write something for when I ask you to factor a square problem with a plus and to factor the cube. Like I said, you shouldn't factor the cube, and then all of a sudden you're at 90 and you can't make any more mistakes to keep an A. Those are on the test. Out of section 1.4, super common for students to factor cubes wrong. Cubes, when they factor, the first parenthesis has 2 terms, the second parenthesis has 3 terms. You don't get a cube in your answer. And then squares with pluses are always prime. Those are hugely common mistakes when I wind up grading the tests. Bryce?
Can you do number 9?
Sure. So number 9, no, yeah.
How
With,
come then
oh,
on 13?
so 13. So problem 13, I'll try to squeeze in here. It's partially prime. I wouldn't say it's completely prime because I can write something that's equivalent to the original problem that isn't exactly the original problem. On 13 in section 1.4, there's a common factor of 2. So it technically does factor because I could factor out a 2. So once something has a common factor, it's not proper to say that it's prime because so I can factor out a 2. When I factor out a 2, I'm left with a b squared plus 25. Unlike the problem that I did 23, I factored out a 2, and then what was left in the parentheses factored, and I got something that was completely different than the original problem. Whereas in problem 13, I can factor out a 2, but the contents of the parentheses I can't go further with. So if you did this on your test, and then next to it wrote prime, I wouldn't take points off because the b squared plus 25 part is prime. It's just that the original problem's not prime because once something has a common factor, it can't be considered prime. But you just can't go further like I did. 9's a good question. 9 is not a test-worthy question, but it's a skill that if you're going to Math 151 that you should be able to catch. And even more important, if you're going to calculus, you should be able to sneak this out and do well on this. So this right here is a square problem with a minus, so it's going to factor. So the initial problem, it's a square problem because the exponent is a 4, and 4 is a multiple of 2. And 16 is a square because it could be written as 4 times 4. So it's going to factor. And I factor by, I divide the exponent by 2. And I take the square root of the number. And you get 2 essentially identical parentheses, one with a plus sign, one with a minus sign. So when I go to factor this, I make 2 parentheses. Each parentheses is just going to have 2 terms. I divide the exponent on the x by 2. And 4 divided by 2 is 2. And I take the square root of the number. Usually when we're dealing with square problems, we're done after we do that. But what's left are 2 parentheses. The first parenthesis, so if I look at my answer, I should realize that one of them still factors more. So this is partially correct. It's partially factored. But anytime I factor, especially if a factor has a square in it, there's a chance that it factors. The x squared plus 16 part of my answer is a square problem with a plus, and that's prime. But the x squared minus 16 is a square problem with a minus, and it still factors again. So this is more complex than I'd put on a test, but not a horrible problem. So what I'm going to do is the x squared minus 16. I'm going to factor it more because when I factored, I divided my exponent by 2. Anytime you have an x squared, there's a potential to get something that factors. The x squared plus 16 is a square problem with a plus. It doesn't factor. But the x squared minus 16, it does factor. I divide the exponent by 2 and I take the square roots of the number, and I get essentially two identical parentheses, one with a plus, one with a minus. Sean?
When you first factored out with two parentheses,
Uh-huh.
the x squared.
Oh, it should be 4. See, I made a mistake. Thank you, Sean. So this should be x squared plus 4, x squared minus 4. Thank you, because this is going to be videotaped, and then I'll a bit horrible. So I forgot to take the square root of the 16. Thanks for catching that before I put this on. Yeah, gosh. I used to give extra credit when students found mistakes, and then students would be getting 50 points extra credit because I make 50 mistakes, and it was shocking how much extra credit I gave out. So I should have written this. Because when I factored the x squared minus 16, I forgot to take the square root of 16, which is 4. And then the x squared plus 4 is a square problem with a plus. It doesn't factor. The x squared minus 4 is a square problem with a minus. It does factor. But this isn't test worthy. At least not in an in-class test. I wouldn't give that as a trick. So every problem that I did today, I factored and stopped, because every problem in section 1.4, as well as 1.1, 1.2, and 1.3, the instructions somewhere in them said factor, and they didn't have an equal sign. I need to start section 1.5. In section 1.5, every problem has an equal sign. Some of the problems I'll need to factor, but every problem in section 1.5, my answer is going to be like x equal to a number, or y, if I'm using the letter y, equal to some number. And most of the problems have two solutions. And ultimately, my goal for any problem in section 1.5 is to get numerical or number answers. And you only get number answers when the original problem has an equal sign. If the problems don't have equal signs and factoring's involved, you factor and you stop. When problems do have equal signs, then you expect to get numerical answers. You may or may not have to factor. The first few problems in section 1.5 are almost supposed to be insultingly easy. Each one of these problems is factored and set equal to 0. But when you are presented with a problem with an equal sign, you're expecting to get numerical answers. If you're presented with a problem that's both factored and set equal to 0, then it's easy to get the numerical answers. You basically can get them just by looking at the problem if you've done enough of these. So once a problem is both factored and set equal to 0, I get the numerical answers by dropping the parentheses and taking each factor and separately setting it equal to 0. So for each of the problems between 1 and 6 that are both factored and set equal to 0, I'm going to get the numerical answers by dropping the parentheses, taking each factor and separating it, setting them equal to 0 separately. And when I don't have fractions, I get my numerical answers quickly by either adding or subtracting, and sometimes I'll have to divide if that's an issue. So to get the numerical answers for 2, I took each factor, set it equal to 0. The factor of x plus 3, I subtracted 3 from both sides and got x equal to negative 3. The factor of x minus 5, to solve for x, I add 5 to both sides and get x equal to 5. There's many ways to write my answer to this problem. I can write x equal negative 3, x equal to 5, or I can just write one x down and write a negative 3 comma 5. That would be okay. And if I didn't even write the letter, if I just wrote negative 3 comma 5, that would also be okay. So all of these are three different ways to write the same answer. They're all correct. The nice thing about when I have problems with equal signs is they're easier to check. When you have a factoring answer, you have to check by foiling, and foiling is harder because I can't use my calculator. To check an answer, I should put the answer back into my problem and see if I get a true statement. So to check the x equal to negative 3, I'm going to take each of the x's in my original problem and put a negative 3 in its place. So I'll go negative 3 plus 3 times negative 3 minus 5. Leave the right sign of equal to 0. My answer is correct if when I simplify the left side, I get the same number as the right side. In this case, is 0. And the beautiful thing is I have a calculator that will do this for me very nicely. So I can just do this quickly. I'll go parentheses, use the negative in the bottom of my calculator, and then 3 plus 3, close out my parentheses, and then parentheses, negative in the bottom of my calculator, 3. And now this minus that's between two numbers is the minus below the times above the plus. Negative numbers are negatives in the bottom of the calculator. Negative between two numbers is a negative above the plus sign. And when I hit enter, this tells me that I get 0 equal to 0, and I put a check sign because that's a true statement. If when I hit enter on my calculator, I would have got something like 7, then it wouldn't have been right. Like for some reason, if I thought, I'll say that x equals 3 is not a solution. So if you just wrote down the answer 3 and thought it was right, I can show you that it's not right, because if I plug 3 in for the x's without the negative sign, I'd go 3 plus 3 times 3 minus 5 equal to 0. What happens when you get an answer that doesn't work is like this. So I'd go 3 plus 3 parentheses 3 minus 5 parentheses. This would give me negative 12 equals to 0, and that's a false statement. So for an answer to be correct, when I plug it back into the original problem, I need to see a true statement when I do my checking. And because 3 isn't a solution, because when I plug it into my original problem, I get negative 12 equal to 0. So solutions can be checked. And because I'm not dealing with letters, once I plug the numbers in, I can check via my calculator. Similarly, I can check 5. To check the x equal to 5, I'd go 5 plus 3 times 5 minus 5 equal to 0. And I can use my calculator if I want to, but I don't have to. But I can go 5 plus 3 parentheses, parentheses, 5 minus 5 parentheses, and this gives me 0 equals to 0. So that's also a solution. Any other number that you gave me, negative 5, 1700, those won't be solutions. There's only 2 solutions to that problem. Generally, you get as many solutions as you have parentheses when something's factored. So 4 is similar. 4 is going to have fraction answers, which without a calculator are a nuisance to check. With the calculator, fractions aren't hard to check at all. So I'll show you how to check fractions with whatever calculator you happen to have. So 4, I'm going to get 2 answers again. And just like number 2, if a problem is set equal to 0 and factored, I get my solutions by dropping the parentheses, separating each fraction and setting each one separately equal to 0. Each one of the problems takes 2 steps to solve. And each one of the problems is going to give me a fraction. It's probably, if I'm using my calculator, as easy to change the fraction to a decimal on my calculator to check, but I'll check with the fraction. Anybody so talented that they can do this 2x minus 3? What do you get for that one?
Oh, no, I said I didn't get the first one.
Okay. So for 2x minus 3, there's 2 steps to solve this. I need to get the 3 and the 2 detached from the x. And I detach them using the opposite of how they're attached. The 3 is attached by minus. The opposite of minus is plus. So I'm going to plus 3 on both sides to detach the 2x. detach the 3 from that side. So if I did that, on the left side, the 3's would cancel. I'd be left with the 2x. On the right side, 0 plus 3 is 3. And then I need to detach the 2 from the x. Since the 2 is attached by multiplying, the opposite of multiplying is dividing. I'm going to divide both sides by 2. And then I'm going to get x equal to 3/2. I'm going to go ahead and check that real quickly just to show you that it works, and then I'll do the other side. So 3/2. Not that that looks like 3/2. So if I wanted to check, because I wasn't sure I did math correct, I'd go like this. I'd go 2 times 3/2 minus 3, and then 4 times 3/2 plus 5 equals to 0. Fractions are a nuisance, but not so much with my calculator. This calculator does fractions really well. I'll do the fraction calculator and the non-fraction calculator so you can see the checking. So for this calculator, I'll go parentheses to check, and then 2, and then times, hit my n over d fraction key, and type 3, and hit down arrow 2, and then I'll hit my right arrow and then my parentheses. That's the, oops, I forgot the minus 3. I'll go backspace, minus 3 parentheses. So that's the first parentheses. Hopefully it's, can you even see it or not really?
Bring it down a little.
Yeah. Is that even okay still? It's tough on this. If I shut that off, does that make it better or worse? Or? Huh? Turn out the front lights. All right. So that's half of it. And the other half, I'll go parentheses, and then 4 times. I probably don't really need the times, but is that better or worse? Or?
It's better.
Okay. So then I'll go 4 parentheses, then 4 times n over d for my fraction, and then 3, down arrow 2, right arrow, plus 5, close out my parentheses. And when I hit equals, it better say 0 because the other side is already 0, and it does. So this solution checks because when I plug it in, I get a true statement, so that's good. On my graphing calculator, to do this, it doesn't do fractions so well. On my graphing calculator, I check like this. I'd go 2 and then times 3 divided by 2. So for the fraction I write as 3 divided by 2. And then minus 3, close out my parentheses. And then parentheses, 4 times 3 divided by 2, and then plus 5, and close out my parentheses. So for the fraction, I have to use the divide key as opposed to the fraction button. So 2 times 3 divided by 2 minus 3, 4 times 3 divided by 2 plus 5. When I hit equals, I get a 0 again. And that makes a good answer because the left side equals the right side, so my answer is correct. So 3/2 is one of the two solutions. What's the other solution? -5/4. Thanks, Manuel. -5/4 is going to be the other solution. I get that similarly. I'm going to minus 5 from both sides to detach the 5 from the left side. When I minus 5 from the left side, it leaves me the 4x. On the right side, 0 minus 5 is -5. And then I divide both sides by 4. On the left side, the 4's cancel, leaving me with the x. On the right side, I get -5/4. I prefer improper fractions to mixed fractions. If you wrote -1 1/4, it's okay. I prefer improper fractions to decimals, but if you wrote -1.25, it's okay as well. So for an answer, as long as I see those two numbers, 3/2 and -5/4, the having x written next to each of them or having x written anywhere is optional. So I would probably, if I was writing an answer on a test, I probably would write that. I could live with this. If you wrote 1.5 and -1.25, I can live with that even without the x equals. When fractions have decimals that terminate, it's not such a bad thing to give decimal answers. Generally, you only give decimal answers if the problem started with decimals. If the problem doesn't have decimals to start, you usually don't insert decimals in your answer. So that's 4. 5 and 6 are very possibly candidates for the test, and both 5 and 6 have 3 answers because there's kind of 3 x's in the problem, and it's super easy to miss the trivial answer. So I'll do both 5 and 6. So 5 gives me x times x minus 1 times x plus 2 equal to 0. 6 gives me 2x times x minus 3 times x plus 5 equal to 0. There's, in some sense, 3 problems to solve for 5 and 3 problems to solve for 6. Although in 5, one of the problems that needs to be solved requires no algebra, gives a solution, but a lot of students miss it. So just like for 2 and 4, where I drop my parentheses and set each part equal to 0, that's what I'm going to do for 5. For 5, there's actually 3 parts that need to be set equal to 0. And I'm going to get 3 answers that all will check. The first answer that I'm going to write down is 0. That's what I get by setting the x equal to 0. And there's no algebra, so it's easy to miss. Any factor that has an x generally produces a solution. And 0 is going to be a solution. And I don't think I have time to check, but it will check. The other 2 are easy. For the x minus 1, you add 1 and get x equal to 1. For the x plus 2, you minus 2 and you get x equal to minus 2. So the answers, there's actually 3 answers. I should check the 0 just to show you that it worked. The answers are 0, 1, and negative 2. When you get answers, they have to be, if you're checking them separately, and you don't have to check every answer. Usually if one of your answer works, then maybe you didn't make a mistake the rest of the way. But for checking, if I wanted to check the 0 just to show you that it works, to check the 0, I'd go 0 times 0 minus 1 times 0 plus 2 and see if that equals to 0. And it will. So if I did this, I'd go 0 parentheses 0 minus 1 parentheses 0 plus 2. So I can only enter the left half. The right half is already done for me. For this to be a solution, it needs to say 0. And it does. So this gives me 0 equals to 0. So when I check the x equal to 0, I get a true statement that makes it a solution. Even though it didn't require any algebra, it's a solution that needs to be included in my answer. 6 is similar, but 6 is in some sense easier. It's also going to have 3 solutions. And each of the 3 solutions will also check. What do you get for when you set the 2x equal to 0? You get no. So if you got negative 2, you minus to get the x detached from the 2. The 2 and the x, because the 2 is multiplied by the x, you have to do the opposite of multiplying, which is dividing. The only time you add or subtract is like here I subtracted 2 and got negative 2 because the 2 and the x, the 2 was added. The opposite of adding is how you detach it. The opposite of adding is subtracting. Here, the 2 is attached by multiplying. The opposite of multiplying is dividing. I detach it by doing the opposite. And the only time you subtract is when something is added. But if something's multiplied, you divide. 0 divided by 2 is 0. If I wasn't sure about that, on my calculator, I could form a fraction. I could hit the N over D button and type in 0 and 2 and then hit enter. Or if I didn't have an N over D button to figure out what 0 over 2 is, I can divide and do 0 divided by 2. My calculator tells me that that's 0. So any fraction with 0 in the numerator is equal to 0. So one of my answers is going to be 0. And the other ones are easy. When I minus 3 from both sides, I'll add 3 and get x equal to 3. And minus 5 from both sides here, I'll get x equal to minus 5. So the first 6 problems all have parentheses. But they have parentheses and they're set equal to 0. Basically, you get as many solutions as there are x's, and in each one of those problems, there's either 2 or 3 x's, so I get 2 or 3 solutions. Let me jump down to 25 through 32 temporarily, and then I'll go backwards, because 25 through 32 are problems that have parentheses, but they're not set equal to 0, and they're very different. Problems that have parentheses that are set equal to 0 are basically easy, what these have are parentheses, and they're set equal to 0. And then for those, you drop the parentheses and set each equal to 0. But for 25 through 32, they have parentheses, but they're not set equal to 0. Absolutely guaranteed, the answers that you'd get by setting the parentheses equal to 0 would be wrong. If I tried to do 26 like I did the other problems, like I guess it would seem like I should just be able to set x equal to 6 and x minus 1 equal to 6. This is the wrong method. So these problems that have parentheses that are not set equal to 0, you just can't do this. You just can't go x equals 6, x minus 1 equal to 6, and add 1 to get x equal to 7, because that's going to produce answers that don't check. If I tried to check x equal to 6, I'd go 6 times 6 minus 1 equals to 6. I don't even need a calculator for that. This is 30. This is 6 times 5 equals to 6. That's 30 equal to 6. 6 is not a solution to that problem. For the next answer, 7, I'd go 7 times 7 minus 1 equal to 6. That's 7 times 6 equal to 6. That's 42 equal to 6. That's not a solution either. So what I did for problems 1 through 6 won't work for problems 25 through 32. I can't just drop the parentheses and set the contents equal to the right side. That only works when the right side is 0. For each of the problems between 25 and 32, the factoring that's given to me is not beneficial. I have to unfactor it, multiply out, clear the factoring, set them equal to 0, and then solve them like 1 through 6. They're way involved problems. So for problems 25 through 32, it's not, you can't just drop the parentheses. You can't just drop the parentheses and solve the equations. What I need to do is I need to clear the parentheses, combine like terms, then set the problem equal to 0. And then refactor, and then solve like numbers 1 through 6. So these are way involved problems. So the difference between 1 and 6 that had parentheses but equal to 0, and problems 25 through 32 that have parentheses but not equal to 0, is I just can't take the contents of the parentheses and set it equal to the right side. That won't work. What I need to do is, any of the problems between 25 and 32, is get rid of the parentheses either by using the distributive property or foiling, combine any like terms that need to be combined, set the problem equal to 0, factor it, and solve. They're way involved problems. So a problem like number 26 that has parentheses but it's not set equal to 0 is the worst kind of problem I could possibly give you. So for this problem, the first step, first, I'm going to clear the parentheses. That's just by distributing. It's not foiling. I'm going to multiply the x that's next to the parentheses by the contents of the parentheses. And the multiplications I need to do there is x times x, which is an x squared, and x times minus 1, positive times a negative is a negative. It's optional whether I put the 1 next to the x or not. I can write minus 1x or minus x. So whether you have the 1 in front of the x or not, that's That's personal preference. So second, if it was necessary, I'd combine any like terms. That's if I FOILed. When I FOIL to clear the parentheses, there's going to be like terms. But here, on the left-hand side, you can't combine an x squared. You can't subtract those because they're not like terms. They don't have the same exponent. So on this step, for this problem 26, there's nothing to be done here for this particular problem. Third, I'm going to set it equal to 0. And to set this particular problem equal to 0, the 6 is on the right side. I want a 0 on the right side. I'm going to minus 6 from both sides. And on the left side, because the 6 doesn't have an x, it needs to be written last. And it can't be written with any of the other terms. It can't be combined with any of the other terms. I'll just write it after the other terms. So I cleared the parentheses because the problem wasn't equal to 0. The parentheses weren't helpful. I used the distributive property to do that. There weren't any like terms to combine, so I skipped that. Now I set the problem equal to 0. Now I'm going to factor. That should be easy to factor, but it may, hopefully. But it might be hard for you. It's not horrible factoring because there's not a number in front of the x squared. You should know that the first have to be a couple of x's, that the signs from the template are plus and minus. Anybody so comfortable that they know what the last should be there? 2 and 3 are perfect. The 2 should be positive and the 3 should be negative. My last need to multiply to 6, subtract to 1. The bigger one needs to be negative. So saying 2 and 3 are the perfect lasts. So once you get it factored, now I'm going to drop the parentheses and solve like numbers 1 through 6. So I'm going to go x plus 2 equal to 0, x minus 3 equal to 0. For the x plus 2, I'm going to minus 2 from both sides and get x equal to minus 2. For the x plus 3, I'm going to add 3 to both sides and get x equal to 3. So the answers to this problem are negative 2 and positive 3. I can check them on my calculator super easily. So to check, I'll just squeeze it in here just to show you. The two things that I need to check are negative 2 and positive 3. And I check by going to my original problem and changing either the x to negative 2 or the x to 3. And for the answers to be correct, both sides have to come out to be 6. I use my calculator to do this. For the first one, plugging negative 2 in, I go negative 2, the negative on the bottom of my calculator, then the 2, and then parentheses, the negative on the bottom of my calculator, 2, and then the negative above the plus sign, and then a 1. So that's negative 2 times negative 2 minus 1. When I hit enter, I get 6 equal to 6, so that solution's correct. And then for the next one, I'll go 3 parentheses, 3 minus 1, using the minus above the plus sign. And when I hit enter, I get 6 equal to 6. So those answers are the correct answers because when I plug them into the original problem, I get a true statement. Any other numbers that I'd get if I tried to plug them into the original problem wouldn't check. So each of the problems in the 25 through 32 range will require at least 4 of these 5 steps, probably all of the 5 steps. If I went to a problem like 28, again, it would be wrong for me to go x minus 1 equal to 12, x minus 2 equal to 12. I won't get the right answers if I do that. So the common mistake is just to drop the parentheses and set the parentheses equal to the right side. That strategy only works when the right side has a 0. So because there's not a 0 over here, I need to unfactor. I'm going to go through the exact same steps that I did before. So first, I'm going to clear the parentheses. And in this case, it's a foiling to clear the parentheses. Bless you. So I'm going to do firsts, which are x times x, outers, which are x times minus 2, inners, which are minus 1 times x, and last, which are minus 1 times minus 2. So I'm clearing the parentheses, and this is going to give me x squared minus 2x minus 1x plus 2 equals to 0. And then second, and it's actually going to need to be done here, I'm going to combine like terms. And that's not always necessary. It wasn't necessary for problem 26, but it is here. The outers and the inners, when I FOIL, are like terms. They both have negatives in front of them, so when I combine, I add the numbers and keep them negative. Should be equal to 12 here. When I FOILed, that 12 shouldn't magically turn to a 0. So I went through my first step. I cleared the parentheses by FOILing. I mistakenly wrote 0 on the right side when I should have written 12. I combined like terms on the left side. Now I'm done with the second step. The third step is to set it equal to 0. And I set it equal to 0 this time by minusing 12 from both sides. On the right side, the 12s just cancel, and I get a 0. But on the left side, the x squared and the 3x come down, but the numbers have opposite signs, so I subtract and take the sign of the larger. And I'll get a minus 10. 2 minus 12 is minus 10. My next step is going to be to factor. And again, it's not supposed to be hard factoring this particular problem. I should know that the first are a couple of x's, that my signs are plus and minus, and my last are going to be, hopefully those come easy. Two and five are perfect. And now fifth, I'm going to drop the parentheses and set equal to 0 and finish like numbers 1 through 6. So I'm going to go x plus 2 equal to 0, x minus 5 equal to 0. For the x plus 2, I minus 2 from both sides and get minus 2 for an answer. For the x minus 5, I add 5 to both sides and get 5 for an answer. So my answer to this are the numbers -2 and +5, which can be checked by just throwing them back into the x's in the original problem and breaking your calculator out. So each of the problems between 25 and 32 is significantly more complicated than the problems between 1 and 6. The fact that they're factored is not productive at all if the problem's not set equal to 0. I'll do 30, then I'll have to jump back to some of the earlier problems because 30 has hard factoring in it. And I'm not checking this, although checking it would be a smart thing to do. So 30 has the same sort of issue. It has a factoring, but the factoring is only productive when the problem is factored and set equal to 0. The nice thing about this particular section is when you have an equal sign, you're getting numerical answers. If you don't have an equal sign, you kind of factor and stop. So first, I'm going to clear the parentheses. And I have to know how to clear the parentheses. And in this case, it's not a foiling. To clear the parentheses, I just multiply the 3x by the contents of the parentheses that it's attached to. So I go 3x times x and 3x times minus 1. 3x times x gives me a 3x squared. 3x times minus 1 gives me a minus 3x. I'm going to bring down the minus 4, but not multiply it by the 3x because it's not in the parentheses that the 3x is attached to. Second, I'd combine like terms when needed. It's not needed here. on the left side, there aren't terms that can be combined. So on this particular problem, number 30, I can skip that step. Now I'm going to set it equal to 0 by minusing 2 from both sides. When I minus 2 from the left side, I lined up the 2 under the 4. Both the 2 and the 4 on the left-hand side have minuses in front of them. When the numbers have the same signs, I add the numbers and keep them negative. Ugh. Good, this problem has an evil trick in it. Now I'm going to factor and set each factor equal to 0, and it has a trick that's important. Because it has a factor without an x. So fourth, I'm going to factor. And if I factor properly, I'll get the right answer. If I don't factor properly, I won't get the right answer. Here there's a common factor. Anytime I go to factor, I should also factor out the common factor first. There's a common factor of a 3. When I factor out a 3, I'll divide each of the numbers by 3. In front of the x squared, I'd get a 1, because 3 divided by 3 is 1. In front of the x, I'd get a 1. And in front of the 6, I'd get a 2. So that's the beginnings of factoring. If you use bottoms up won't factor it perfectly well, because bottoms up requires the common factor to be removed first before you factor it. It's not completely factored, it's partially factored by pulling out the common factor. After I pull out a common factor, I have to look at the inside of the parentheses and decide if it factors more, and this one does. And the inside of the parentheses, I know that the first have to be a couple of x's to get my x squared, and my lasts have to be, what are they? 1 and 2 are perfect. They have to multiply to 2, subtract to 1. The bigger number has to be negative, so they're 1 and 2. So now I'm done with the fourth step. Now I'm going to set each factor equal to 0. So I'm going to drop the parentheses, set the factors equal to 0. And an evil thing comes up here. That this is the classic -2 mistake on the test if I gave this trick. So I set each factor equal to 0. Only factors with x's give solutions that check. 3 is not going to check. 3 will not be a solution. Even though this says 3 equal to 0, a factor without an x will give a solution that doesn't check. I can immediately discount this, and I'll show you that it doesn't check here in a second. But 3 is not going to be a solution. The other 2 solutions that I get from the factors that have x's will be solutions that check. I claim the only solutions are -1 and +2, and that 3 isn't a solution. So I'll check all of these just to show you that this solution that came from a common factor without an x isn't a solution. When I go to write my answer, the only answer I'm going to write is the -1 and the +2. I have to steal this page away. Let me just try to do it like this. So for checking, to show you that the 3 doesn't work, I'm going to plug the 3 in for x in the original problem. I'll go 3 times 3 times 3 minus 1 minus 4 equals to 2. That's just plugging 3 in for the x's into the original problem. And when I do this, on my calculator, I can go 3 times 3 parentheses 3 minus 1 minus 4, and this gives me 14 equals to 2. That's not a valid solution. That's why I said it won't be a solution. For the -1, I can go 3 times -1 and then -1 minus 1 minus 4, and that should equal to 2. So I'll go 3 times minus in the bottom of my calculator 1 parentheses -1 minus 1 parentheses minus 4. When I hit enter, this gives me 2 equals to 2, so that's a solution that checks. And similarly, if I try to check the 2 and go 3 times 2 times 2 minus 1 minus 4 equals to 2, I'd go 3 times 2 parentheses 2 minus 1 minus 4, and I get 2 equal to 2. So only factors that have x's give solutions that check. Factors without x's you could just completely ignore because the number that gets generated from those is a solution that won't check. That's way hard. I may or may not put something that hard on a test. I kind of think I wouldn't, but it's a candidate to be a test question. But when we get to the review tomorrow, we'll find out better. So that's 25 through 32. 7 through 18 are moderately easy. For 7 through 18, I'll just pick a random one that's hard, like 15. What each of these have in common is that they're already set equal to 0 and there's no parentheses. So for each one of these, they're set equal to 0, which is good. There's no parentheses. So there's no parentheses to clear. For each one of these, you just factor the left side first. So my goal is going to be to factor the left side. Then after I get the left side factor, I drop the parentheses and solve like I did for numbers 1 through 6. This is hard factoring. There's no common factor, but it's still factorable. To factor this, I'm going to use bottoms up. When there's a number in front of the x squared that you can't factor out, this is when we use bottoms up. So my first step is to factor. And because of the 3 in front of the x squared, I'm going to use bottoms up. So I'm going to multiply the 2 and the 3. Now I'm going to factor this, and this is moderately easy factoring because there's no number in front of the x squared and they have nothing but pluses. This is reasonably easy to factor. My lasts have to multiply in 6 and add to 5. My lasts are going to be 2 and 3 because 2 times 3 is 6 and 2 plus 3 is 5. If you put 6 and 1, those are the wrong lasts because 6 and 1 add to 7. Because I started off multiplying by 3, I'm going to divide by 3 to finish up my bottoms up and finish up my factoring. The first fraction, I'm going to bring the 3 and write it in front of the x. The second fraction reduces to 1. So that's the factoring part of this step. And now I'm going to just drop the parentheses and set each factor equal to 0. And then get my answers, and I won't have time to check. So it was set equal to 0. There's no parentheses. That's a good situation in that I can jump straight into factoring the left side. I have to know the proper factoring strategy. Because there wasn't a common factor and there was a number in front of the x squared, I used bottoms up. For the first factor, for the 3x plus 2, takes 2 steps to solve. I have to divide both sides, or minus 2 and divide by 3 and get negative 2/3 for one of the answers. For the x plus 1, I minus 1 from both sides and get x equal to minus 1. So for each of the problems between 7 and 18, all you have to do is factor the problems, and you have to know the proper factoring strategy. After you get the problems factored, you solve them just like 1 through 6 by taking each parentheses and setting them equal to 0. The last group of problems I haven't touched on, 19 through 24, these are problems that are similar to 7 through 18 in that they're set equal to 0, which is good, so there's nothing to multiply out. in problems 19 through 24, I'm going to factor the left side to start by removing the GCF first. So first I'm going to factor. If I look at a problem like 24, which is 2x squared minus 18 equal to 0, there's no parentheses to multiply out. It's set equal to 0. That's a good position. In order to get answers, I have to have the left side factored. And the first step in factoring for these problems is to remove the GCF. And in problem 24, both 2 and 18 are divisible by 2, so I'm going to factor out a 2. When I factor out a 2, I divide each of the numbers by 2. I get a 1 in front of the x squared, and the 18 turns into a 9. So I remove the GCF. And now I'm going to factor the contents of the parentheses. So for every problem between 19 and 24, there's a common factor that you factor out first. Once you pull out the common factor, what's left in the parentheses is going to factor more. If it doesn't factor more, you don't have it right. And the problem with this particular section is that the factoring is scrambled. So now I have to know how to factor x squared minus 9, even though it's not in section 1.4. This is a square problem with a minus. So it factors, and you get two essentially identical parentheses, one with a plus sign, one with a minus sign. I divide the exponent of the letter by 2 and get x to the first power. I take the square root of the number and get 3. So I factored, I removed the GCF, I factor the contents of the parentheses, and now I'm going to set each piece equal to 0 without the parentheses. So I'll go 2 equal to 0, x plus 3 equal to 0, x minus 3 equal to 0. Only factors with x's give a solution. So 2 is not going to be a solution. So 2 is not a solution because the factor doesn't have an x. If I try to put 2 back into the original problem, it won't check. Only factors that have x's give solutions that check. The solutions that will check to this problem are the answers that I get when I take the x minus 3 and the x plus 3 and set them equal to 0. The x plus 3, I minus 3. The x minus 3, I add 3. And the answers to this problem are just 3 and negative 3. And 2 is not an answer. If I tried to check it, if I actually had time to check it, you'd find that it doesn't work. If you instinctively wrote this for your answer, you put a plus or minus sign next to a 3. That's a beautiful way to write the answer. Anytime you get the same number, both positive and negative as an answer, the shorthand is to write a plus and minus symbol next to the number. It's permissible. So sorry for the lateness. Tomorrow, I'll do the review, and then on Wednesday we get the test. So I've done problems. I really focused on 1 through 6 and 25 through 32 with the hopes that the middle problems aren't as bad because the skills in the middle problems are the skills in the top and the bottom problems. But if you get stuck, come and ask me questions, and I'll try to help you out.
When will you have this posted?
It's an old version of it.